all of our panelists in the meeting. So welcome everyone to this safety webinar put on by the Transport Project. My name is Paul Sanstead. I'm the Director of Technology and Sustainability here. I've been with TTP for over 6 years now, and we have put together a great, very informative presentation for you all today that will review our recently published facility modification guidelines for the maintenance and repair of natural gas vehicles. And a real quick look at our agenda for today. I'll start with some opening remarks and introductions, give you all a quick review of the Transport Project, what our role is in the transportation sector, and also give you an overview of why these maintenance facility modification guidelines were developed. And then, of course, we'll get into a review of the guidelines themselves and some of the changes that have occurred since the last publication. On the right side of the screen, you will see the primary maintenance facility modification topics we'll be covering today. Of course, safety is paramount here at TTP and within the Technology and Development Committee, and that really is the guiding principle for developing and reviewing all the different for the maintenance facilities. So with safety, of course, comes training, and we're going to also get into a lot of the nuances between minor and major repair areas, how to mitigate those indoor hazards with CNG, analyze the facilities, prep vehicles for going inside a facility for service, and a lot of those very specific topics on ventilation, gas detection, sources of ignition, and electrical classification. So real quick, in terms of some opening remarks, just have a few housekeeping items. Please keep your microphones muted and keep your cameras off unless you're speaking. I would prefer if everyone puts their questions into the Q&A window in Teams, or if you prefer to ask those verbally, we will open up the mics towards the end of our hour today, and we will use the raise hand feature for asking any verbal questions. I would also like to note that this webinar is being recorded. That is primarily just for recall purposes. A link to this recording will be available in TTP's member portal, which is available to members only. And with that, I also want to start with an antitrust and confidentiality statement. In terms of antitrust, the purpose of this meeting is to discuss and strategize efforts of the Transport Project and its members. This meeting is open to TTP members and invited guests only. Nothing in this meeting is intended to result in unlawful agreements, explicit or implicit, between competitors to fix prices, limit production, allocate markets, establish discriminatory industry codes and standards, or otherwise unreasonably restrain trade. In terms of confidentiality, we encourage the information here today to be used by the participants. Feel free to use it, discuss it in future endeavors, but we ask that neither the identity nor the affiliation of the speakers nor that of any participant be revealed except upon expressed permission of that person. If you are sharing information during this webinar and you would prefer that TTP not distribute the information, please inform us so that we may honor the request. TTP staff will inform participants if it is recording the meeting, which we are, or using AI to transcribe the meeting, which we are only in the sense of the Microsoft Teams recording. All AI transcription, note-taking, or recording applications separate from those deployed by TTP with participant consent are strictly prohibited. So I'll pause for any questions that anyone might have on that before I move forward. And I'm not seeing any hands raised. But very good. Moving right along, I would like to introduce Mike Zimmerman, who is the president of Cummins Clean Fuel Technologies, and he is also the vice chairman of our board of directors. Mike is going to kick things off here with a few introductory remarks. Go ahead, Mike.
Yeah, thanks, Paul. Thanks to everybody who's joining today. This is exciting for us, being members of the Transport Project for, oh gosh, over 10 years now, I'm sure. And we've watched this industry really, really grow and start to kind of distill down into something that's working very, very well. You know, you'll know as you get more involved with our organization that our member companies are passionate about natural gas as an alternative fuel, especially renewable natural gas. And like I said, it's very safe, but it's got to be handled correctly. And so your interest in this discussion today really speaks for the fact that you all are companies that want to do it right. You don't want to leave anything to chance. And if you're not familiar, I think this is a wonderful opportunity to pick the brains of the guys who've been at this for a long time, and sometimes learn through the school of hard knocks how to do it better. So this is a wonderful group to be a part of. I think that's about all for my intro. So Paul, if nothing else, take it away.
All right, Mike, thank you so much. And we do appreciate all your support and leadership here at TTP. On to another few opening slides on the Technology and Development Committee. For those of you who are joining us who are maybe not familiar with TTP or the Technology and Development Committee, we are focused on safety best practices, codes and standards, and developing resources that support the natural gas and hydrogen vehicle industries. Within the Technology and Development Committee, there are 8 key issue work groups where we host meetings, we host webinars, we are committed to evaluating each one of the topic areas listed on the screen. And for the purposes of this meeting today, this webinar, this is a product, everything you're going to hear today is a product of the Facility Modifications Working Group, which is a subcommittee of the broader Technology and Development Committee. So we're going to hear from Leo Thomason in a few slides. Leo is our working group leader, but just want to highlight the fact that we within the committee are committed to supporting the industry and producing the resources and materials that really support cost-effective and efficient operations. A little bit more in terms of our focus areas: safety, sustainability, and industry advancement. I've already said several times we take safety seriously. It really is at the forefront of everything we do here at TTP and within the committee, and that starts with training. Certification, inspections are a big part of that as well. And you'll see on that last bullet point, we focus on those maintenance facility modifications, which is what we'll be talking about today. And of course, with sustainability, we try to do our best to highlight the fact that natural gas, particularly RNG, is a clean, cost-effective, low carbon footprint fuel solution for heavy-duty trucks. And industry advancement, we try to do our best to secure R&D funding through DOE funding appropriations, and that funding is then put towards various research, development, deployment, and demonstration projects for vehicles heavy-duty vehicles powered by natural gas and hydrogen. We also dabble in the virtual pipeline world as well, and in the high horsepower world in marine and rail applications. Hydrogen is also a focus for us within the committee. We look at those hydrogen internal combustion engines and the fuel cell electric vehicles. All right, so without further ado, let's get to the real reason we are all here today, and that is to talk about these facility modification guidelines for maintenance and repair of natural gas vehicles. This is our latest publication to review the fleet facility code requirements, advanced awareness of CNG hazards that exist inside a maintenance facility and repair garages, and enhance the safety of CNG fleet operations. This resource was recently published last month, and we made that announcement with the press release on March 24th. You're going to hear from a lot of the contributors and the subject matter experts that contributed to this document and supported the development of it. So I want to recognize them in this slide. So Cummins Clean Fuel Technologies, we're going to hear from Chris Culberson today, Jim Leonard with J.R. Leonard Construction Company, Leo Thomason with AFVI, and Chip Wirtz with WM. We're going to hear from them in the upcoming slides. But thanks, guys, very much for your time here today and all of your support throughout the process of developing this document. Real quick history lesson. This technically is the third edition of this document, coming from a first edition published in 2012 by the Clean Vehicle Education Foundation, and then again in 2017 was republished by Natural Gas Vehicles for America, which is our previous name. And finally, we are now in the third edition, published just last month. And there is a real strong focus on reviewing these code requirements that exist in both from International Code Council and the National Fire Protection Association. A total of 7 different codes are referenced in this document. And while the majority of regulations are developed and reference those particular code requirements, the two that are referenced most and are predominant within the various authorities having jurisdiction and their regulations are NFPA 30A and the International Fire Code. So we're going to focus on those two today, but I just want to highlight the fact that there are a multitude of codes out there that specify various requirements for natural gas and hydrogen powered trucks going inside a facility. And with that, I am going to introduce our first speaker. Leo Thomason has 40 years of experience as a technical trainer and consultant in the natural gas vehicle industry. He is an expert in vehicular CNG fuel system installation code, design, and installation requirements, developing AFVI's first CNG fuel system inspector training course in 2005. As a consultant, Leo has evaluated more than 30 existing and planned vehicle maintenance facilities for safe CNG and LNG vehicle maintenance and code compliance. As a graduate from California State University, he holds an MBA in management science and a Bachelor of Science in industrial technology. So, Leo, if you're with us, please go into a review of these the maintenance facility working group, first of all, and then we'll get into some training aspects.
Well, thank you, Paul, very much. First of all, the maintenance facility working group focuses on monitoring and providing input on updates to codes and standards affecting natural gas vehicle maintenance facilities and reporting those impacts back to the technology committee. The working group includes over 35 members with experience across a wide range of facility types, from light and heavy-duty fleets to truck manufacturing, mining operations, dealer service facilities, and truck stop maintenance operations. All right, Paul, can you give me the next slide, please? As part of the document, there is also a section on technical training. And it is important for us to focus on training as an integral part of a maintenance facility, whether it's modified to handle natural gas as a vehicle fuel, or if it's built from the ground up as a brand new facility. It is important that the technicians working on that environment be trained. Virtually all existing vehicle maintenance facilities are designed for gasoline and diesel-powered vehicles. These fuels are heavier than air, and they're both liquid and they're vapor phase. In a maintenance facility designed for these fuels, the hazardous area is from the floor 18 inches up. Natural gas is lighter than air, and in a facility modified or designed for natural gas as a vehicle fuel, the hazard area is from the ceiling 18 inches down. So electrical and heating systems in the ceiling cavity must be explosion-proof. In addition, the codes require that a methane detection system be installed as a safety feature. The technician working within this maintenance facility must understand the properties and characteristics and behavior of the fuel, natural gas that is, and how the methane detection system functions, and what to do when an alarm sounds. So that's just one example of what kind of training we would need. So we would need fuel properties and behaviors and characteristics, and then the components and operation of the methane detection system that exists inside of the maintenance facility. Contrast that with a natural gas powered vehicle that uses this fuel in a compressed state. The pressurized fuel system, in addition to that on the vehicle, may also have a methane detection system installed. While the methane detection system is not required in a CNG powered vehicle, some fleets do put that in as an extra added safety feature. These systems are required on the vehicle to be inspected every year if the vehicle is 10,000 pounds GVW or heavier. The technician working on the natural gas powered vehicle must know how the pressurized fuel system functions, how to properly inspect the system, as well as how to maintain and repair the fuel system. So you can see by the bullet points on this slide that there are several major areas that the technician training should incorporate. But those areas aren't meant to be addressed in isolation. In practice, they're delivered as part of a single structured training program that prepares technicians to work safely and consistently across a wide range of systems and conditions that they'll encounter in a CNG maintenance environment. A structured system is really necessary because that connects the topics into something technicians can actually apply on the job. Would you please go to the next slide, please? One way to think about training is in three different layers. First is awareness, understanding the system and how it's designed to operate. And again, we use the methane detection system in the maintenance facility and on the vehicle as a prime example. Second, there's application, being able to recognize when something doesn't work right or when the condition may require attention or a special procedure. The example there would be trying to do something like hot work, like welding on a natural gas powered vehicle. There are very specific procedures and processes that are put into place if somebody is thinking about doing welding on a natural gas powered vehicle in a maintenance facility that's been modified or built from the ground up to handle natural gas powered vehicles. And third, there's decision making. Know what action to take when a specific condition or unique task is identified. For instance, the technician has to understand what to do, and if the methane detection system were to alarm, what are the actions that need to be taken? Absent being trained properly, the technician would be confused. What is that noise I'm hearing? What am I supposed to do about that? And that's where training becomes operational. Okay, my last slide, please. Facility modifications are critical, but their effectiveness ultimately depends on technicians who are trained to work within those environments. Structured training provides the foundation, but its value is realized in how consistently that knowledge is applied in the working environment. Thank you for listening to me. I appreciate it.
All right, Leo, thank you very much. And we appreciate all your leadership within the Maintenance Facility Modifications Working Group. On to our next speaker. Chip Wirtz is the Director of Fleet Services and the Director of Fleet Services Infrastructure Team with WM. He leads WM's program for developing on-site natural gas fueling infrastructure to support the company's transition from diesel to clean burning renewable natural gas in their fleet of 24,000 heavy-duty collection vehicles. WM operates over 13,500 heavy-duty natural gas collection vehicles with their own on-site natural gas refueling infrastructure at 233 operating locations in 40 states and 4 Canadian provinces. 25 of these locations include public access CNG retail stations. A critical component of WM's infrastructure program includes vehicle maintenance facility upgrades for major repair facilities, of which all 233 operating locations have been completed. So with that, Chip, I'll give the floor to you.
Okay, thanks, Paul. If you want to go ahead and go to the next slide. Yeah, just I think this like kind of rehashes some of the work that we've done in the last 20 years or so within our program. But we have a little out of date, but we now have over 13,500 natural gas trucks operating on the road, 233 stations, 25 retail. We're displacing over 90 million gallons a year of diesel fuel by using CNG rather than diesel fuel. That we're 65% of that is from renewable natural gas from our RNG sites, and we've got 15 RNG sites now operating in the U.S. and we'll be producing nearly 100,000 or 100%, close to 100% of our own internal natural gas use for transportation fuel will be from renewable natural gas by the end of the year. Let's go to the next slide, Paul. And when it comes to hazard analysis and looking at our facilities, one of the first things that Paul mentioned in the beginning, and Leo, was why do we do this? And for us, one of the biggest things it comes down to is we have a saying in our company, and that's that we want to get home safe each and every day. So we want to ensure that the safety of our employees and our people, to give them the tools to do their job in a safe environment, to ensure that building that they're working in is going to be safe for the type of maintenance that they're doing on the vehicles, and it's going to be suitable for that whatever type of truck, whether it's a diesel truck, a natural gas truck, a diesel truck, or a hydrogen truck, whatever fuel type we're using. We want to make sure that working environment that they're in is suited for that type of work. So that the main things that, from an owner's perspective, when we go and look at a facility, one of the first things is, was that building, that structure that they're doing the maintenance in, was it even designed and constructed to be a vehicle maintenance facility to begin with? Does it have the ventilation, are the electrical systems safe for doing that type of work? What's the ventilation? Does the ventilation take into account activities in the typical hazardous areas, which for fuel types are either at the floor level or at this in the ceiling level for lighter than air fuels, and for, you know, towards the floor level, the 18 inches along the floor for you know, for like liquid fuels and diesel and liquid portions of natural gas and LNG format. So the things that we always, the things that we try to look at when we're first looking at a site is, you know, a lot of the items that are listed here: the ventilation, the, you know, the electrical and the lighting. Where is that electrical? Is it in a classified zone? So when you're converting for lighter than air fuels, the area within a, you know, half a meter or 18 inches from the ceiling is the, you know, the area of concern. Then the heating systems, you know, you cannot have temperatures over 750 degrees Fahrenheit. So more often than not, you're reworking the heating system in a building to make it, you know, low intensity radiant heat that's suitable for, you know, working on compressed natural gas vehicles. Also, an area in with respect to that is your other arcing, sparking, and ignition sources. So we often have hot seas pressure washers that have open flame type systems that you can't have those in a natural gas shop. Need to, you know, isolate them from the working areas. Some of the other things that we do when we're looking at our facilities are, you know, what can we do since we're going in and doing a lot of this work? We try to improve the lighting, to you know, improve the, you know, the lighting for the technicians working in the shop. But those are, you know, some of the really the main categories that really come into play. And, you know, if you're doing work where you're trying to lift bodies on vehicles, do you have the height requirements you need? And if you're modifying the heating system and some of the electrical systems, you need to take into account how you're going to reroute those systems so that you can still do body lifting and, you know, lifting cylinders and you know, working with your overhead cranes and any of the, you know, that type of equipment that will be used in the building after modifications are completed. Paul, I think we can go to the next slide. I think that may be the last. Yeah, I guess this one shows some of the details on the area classification zones showing in the ceiling areas, and some of the concerns of open flame heaters, and, you know, that you cannot have ignition sources over 750 degrees. A lot of the systems for the ventilation side of it, if you have a methane detection where the methane sensors are in the ceiling, you know, first you have to identify a leak or a leak of ignition. But then the next thing that happens is that you typically turn on the ventilation systems, and part of that is to also increase ways for fresh air to come into the building. That's usually done through opening overhead doors or through louvers in the walls that are typically down lower at the floor, so it brings in fresh air from the bottom and then exhausts it through the top of the ceiling. I think, Paul, I think Jim is probably going to get into more detail on many of these areas. So I think I'll stop there and we'll wait for questions at the end.
Yes, sir. Thank you so much, Chip. And I should have mentioned earlier in my introductory remarks that we're focused on CNG in this webinar. The guidelines document, which was recently published, does also contain LNG specific content, but for the purposes here today, we are keeping things focused on compressed natural gas. So where these hazards would exist in upper ceiling areas with CNG, some of those are, and Leo brought this up, some of those are at the floor level with LNG. So hazards on both top and bottom areas, depending on the type of fuel you're using. All right. Jim Leonard is our next speaker. He's the president of J.R. Leonard Construction Company. He is a fully licensed general contractor serving the southeastern United States with 45 years of experience in the construction business, 23 years as owner of J.R. Leonard Construction Company, 40 years of wet fuels experience, and 15 years of gaseous fuels experience. Jim has led numerous CNG design build projects that include CNG refueling sites and maintenance facility modifications. In addition to all of his vast experience, Jim is also a member of TTP, NFPA, and is trained in AFEI 401 and 402. With that, Jim, I'll hand things over to you. You're muted, Jim.
Sorry, Paul.
Very good. And we can hear you.
Yeah, I'm sorry. Thank you for that. I appreciate everything. Go ahead and pull up that first slide and we'll get right into it. So for everyone to see here, it's a typical garage. It's a resembles of some of the things you'll run into in a typical shop. Obviously, you have your four walls and a roof, as we would all know, but you have your things that you are looking at that you need to identify that could be potential hazards when you're converting your facilities or building a new facility. And when I go into a facility and I'm asked to come in and figure out what's needed there to put this site in compliance, then I'm going to do my survey, and I'm looking for a lot of things that Chip had just spoke about, Leo's talked about, but specifically I'm looking really hard into conduits in the classified hazardous space up in the ceiling. Are they EMT? Are they below the 18-inch? Are they flexible metal conduits that are not UL listed to be in that classified zone? I'm looking at all those kind of minor things that a lot of people overlook because I have a construction background. I won't say overlook, but I'm just looking into it a little bit harder than most people, because once I identify all the hazards, then obviously I can put together a proposal to bring the site into compliance and eliminate those hazards. But in this photo here, you've got duct work. There's many ways to get a methane source out of the building, different ways, rooftop fans that were shown in Chip's slide. You can put ductwork in and pull it through ductwork and pull it out of the building, but you've got to make obviously a clean path of resistance for that gas to get into that ductwork if you're going to use ductwork to pull it out. But there's a lot of different ways of skinning the cat, and every shop is different. I want to make that clear. Every shop is different. Roof structure plays a huge role into how we determine how we get rid of that methane. Whether it's a gable roof, flat roof, or what have you. But we need to determine what type of building it is. We're looking at the dimensions of it. We got to determine the purge ventilation requirements, how much air we need to move in this facility to purge it of methane should there be a leak. But you're looking at all those things you see in this photo. Where would you mount your gas detection system on the wall? Where find a spot for that? Do we have overhead doors with motors that are up in the classified space, or are they down below the classified space? Because those motors and those garage doors are typically open drip proof motors, which are open armature. They are spark inducing. We look at obviously the heating system. What type of heat system's in there? Is it a open hanging unit heaters that we see a lot in these older shops where they have open type of combustion chambers that you can basically about see the flames in there when they're running. But it goes. But you also consider, again, as Chip mentioned, we got to make sure that whatever's there, if it can stay, that it be in compliant and it doesn't exceed the 750-degree surface temperature of any portion of that heater. So just a lot of things, not complicated, not trying to confuse anybody, but again, every building stands on its own. Every job is different from the next, for the most part, especially some of these older facilities. The newer facilities, pretty much a cookie cutter. You get your standard gable roofs, Most all of your newer buildings are at least 12,000 square feet, and then I'm going to comment on that. If they're more than 5,000, they have to have a sprinkler system in them, or they'll be separated by firewalls. So a lot of things to consider, again, with existing and for new construction. Paul, next slide. There are some of the components of the gas detection system. Obviously, you want the gas detector itself, which is the heart of the system, it and the exhaust fans, but the heart of the system, the device that determines the presence of the gas or the leak, potential leak, is the actual gas detector. You want to make sure it's operating properly and that it is detecting the level of the methane, which in this case within FPA we required to activate the alarm in the gas detection panel at 25% of the lower flammability limits. So you've got that. That's when you're obviously your major component of your gas detection system. Then you have your sources of notification. And in the picture on the left, you see those are notification appliances is what we call those, or NAC circuits. So those notification appliances, those are, in this case in particularly, are the ones that are on the outside of the building in a typical, and I know this is a waste management job because I see the red and greens and how they're designed there. But green indicates that it's safe to re-enter. The red indicates obviously that it's not safe to enter that building. But you would typically have notification appliances also internally on the wall inside the shop, 1, 2, 3, depending on the size and locate, of the building and how it's designed. But you would have a horn and strobe of some type. Varies by manufacturer, but you'd have certainly an audible visual alarm to alert all your mechanics that, hey, there's a problem. Everybody needs to evacuate the building and gather at the muster point outside of the space. Okay, Paul. Other things to consider. Again, we talk about the Class 1 Division 2 area, which is the 18-inch space at the ceiling level. This particular looks like a crane there for lifting bodies off trucks and things like that and pulling motors. So you always have to consider, if you go into an old facility, how is that power being fed to that crane? Does it come from the ceiling and drop down, or does it go up a column and go over and hit the crane motor? Usually the cranes are going to be below the 18-inch as far as their actual motors, because of the structure, the nature of the structure, the steel that's built to the way they're designed and to hang off the steel in the building. But chase down the conduits that feed that motor. Where are they coming from? Are they coming from that ceiling? Are they just open EMT, electrical metallic conduits that are what we call thin wall conduits? If they are and they're up in that class 5, they got to come out and they got to be lowered. So there's again, every job's different, every building's different, and but again, these are things you got to look for when you're installing your CNG, converting your CNG fleet over from diesel or gasoline and want to run CNG trucks. You've got to look at all of the different things that could potentially become sources of a hazard for you. Next slide. There's a lot of talk about, well, do I need to do it? Do I not need to do it? Is my facility a major or minor repair facility? This pretty much qualifies it here. This is right out of the book. In FPA, if it's minor, it has to meet these requirements. It has to be completely defueled 100%. And you can only do routine maintenance work, lubrication, inspection, engine tune-ups, etc., replacement of parts, fluid, brake changes, tire rotations. You can't do anything with working on the engine. You can't leave it in there overnight. You can't work on the fuel system, the CNG fuel system, in any way, shape, or form. A major repair facility, if you bring it in and the level of natural gas in the tanks are at 250 degrees, 250 psi at 70 degrees Fahrenheit, and you plan on working on the vehicle's fuel system in any way, shape, or form, or you need to do any service on that truck to require welding or open flame or torch of any kind, or if you're going to leave it in there overnight, you've got to make, it's got to be considered a major repair area. And there's, in either case, you still have to have a methane detection system. You can't get out of that requirement. You have to do that. That's in the code 2024 in FPA 30A. So it doesn't matter if you want to consider it major or minor, you still got to put in the gas detection system if you're going to have CNG trucks in your maintenance facility. Okay. Just as a snap here of some of the requirements and how they have changed a little bit. As you can see there, 2021 and later, 7.8.11 flammable gas detection required. So we were all operating in the industry under the thought process that we could go into an existing garage prior to 2021 and just run continuous ventilation to purge the building of possible methane releases and to meet the requirement for declassifying the ceiling space at 1 CFM a square foot per National Electric Code. That all changed in 2021 with the later addition, and there's no out on that. You must have a gas detection system, and it must be installed operating properly. If you have, and as far as that goes, if you have failures of that system, it's got to deactivate the heating system and activate the mechanical ventilation if you have any failures in that, like a fault in the panel itself. So it has to be designed and built to be able to do that. It also has to sound an alarm in an approved location, and most usually that's a horn and strobe that's on the wall in the facility. So even though you have a gas detection system, you need to have safeguards in place, or so that if we do have a failure of any kind in that system, that it does something to cause people to react and to understand that hey, we don't really have a leak, but we do have a problem and we need to get it fixed. So as Chip mentioned earlier, and I'm a big proponent of as well, I want everybody that comes to work every day to go home every night. I mean, that's I've been around flammable liquids pretty much my whole life, and have had witnessed a few accidents, and it really drives home the point of trying to take care of your employees in the best way possible. And as owners of fleets, I think it's imperative that everybody understands that let's make sure we take care of those guys. Those are the guys that are out there making us money, keeping the fleets on the road, and let's do the best job we can and put the best possible type of equipment in the facility to make sure that they are safe and they live a long life. So is there another one, Paul? That might be it.
That's your last one, Jim.
That's it. Well, thank you, everyone. I appreciate it.
Thank you, Jim. We'll get into some Q&A later on, so if you can stick around, we will address any questions that our attendees might have. Our next speaker is Chris Culberson. He is the Customer Care Manager with Cummins Clean Fuel Technologies. He has 11 years of experience with Peterbilt motors in off-highway design engineering and field service. He has 3 years of experience with custom vehicle solutions in engineering and operations, 10 years of experience with Momentum Fuel Technologies, which is the Cummins Clean Fuel Technologies former entity, in engineering, service, and training. And Chris has a BS in mechanical engineering from Texas A&M University. So Chris is going to talk to us about a new best practice that is not actually contained in any code or standard today. So this is some very forward thinking that Chris was very helpful in putting together. So without further ado, Chris, I'll hand it over to you.
Okay, thank you. What we'd like to talk about today is, if you remember Jim's presentation just a minute ago, it talks about in IFC, International Fire Code, there is no requirement for methane detection in a minor repair facility, and minor repair facility can be defined if you have below a certain pressure in your fuel system. If you'll go ahead and go to the next slide, Paul. So for natural gas, it talks strictly about pressure. They put in hydrogen, and hydrogen has a maximum volume, standard cubic feet of hydrogen that could come in. We started thinking about this and talking about it, and think that that may be a better practice with natural gas as well. There was a study done by Sandia National Laboratories years ago, and they came up with the 250 psi range in there. But when they did the study, the sizes of the systems were much smaller. Back then, kind of an average fuel system size would be, 80 to 90 DGE. A very large one would be considered 135 DGE. Nowadays, 175 DGE is very common, up to, we've seen some that are 275 DGE. So one of the things that we, are recommending is that instead of looking at just the pressure, maybe we need to go back and we need to start looking at the volume as well with natural gas. Can you go to the next slide, please? So a very close approximation, it's not exact, but it's a close approximation, is to use the ideal gas law. So some of the parameters that we need to run this is, what is the maximum standard cubic feet of methane that we believe is safe to come into a facility? And once we determine that, we can calculate based on current CNG pressure, the approximate gas temperature, and the fuel system capacity. So we need to know all of these things. Temperature has a very big effect on pressure in a fuel system. So getting the gas temperature plays a big role into it. A lot of people have heard of the ideal gas law, pressure times volume equals, a couple of constants times temperature. But we can calculate that and calculate how much allowable volume would be in a fuel system. So that's kind of what step one is laying out. So your allowable volume is going to be your volume that is in your fuel system in liters, and then we're going to calculate that to cubic feet, because that's what we're looking for. We're looking for standard cubic feet, and that 0.0353 is just a conversion factor to convert from liters to cubic feet. Pressure in PSI, we've got to be in absolute pressure. So we're making that calculation. And then temperature is in degree Rankine. So the temperature in Fahrenheit plus 459.7 is a conversion factor for converting to Rankine. The 529 is at 70 degrees Fahrenheit, because that's what everything's going to be related to. But this gives us, when you calculate these, it's going to give you what system pressure you could have at your given temperature and your given capacity of your system in water liters, and be at that allowable volume. So if our system pressure final is less than what my current system pressure is, then that vehicle can enter that facility, according to IFC. As Jim said, if your state or jurisdiction adapts NFPA 52, there is no out that you have to have a methane detection, but a lot of states have adopted IFC instead, and some jurisdictions. So it depends on where you're at. Go to the next slide, please. So this is an example. So if we're saying that the allowable volume of gas is 400 standard cubic feet of methane, which is, we got that value because that's what IFC allows for hydrogen. If we make that assumption, we're going to say, for this calculation, we're going to say that the vehicle volume, the system capacity is 1,000 liters. And we're going to say that the initial gas temperature is 60 degrees Fahrenheit. So when you do this calculation, so it's 400 cubic feet divided by the volume and 1,000 liters converting to cubic feet, and then the temperature conversions and everything, that would mean that our allowable pressure is 148 psi. And so just for reference, that 1,000 liters is going to be approximately 75 DGE. Like I said, that when that paper was written, that study was done by Sandia, that was a very typical volume of a CNG fuel system. But nowadays, like I said, it's 175s are becoming extremely common, and upwards of 200, 250 are not uncommon. I think is that my last slide, Paul? Yep.
Yes, sir. Chris, thank you so much. All right, so that brings us to the end of our speaker presentations today, and I will move on to the Q&A portion of our webinar, and I will allow anyone with questions to ask them verbally by raising your hand, or feel free to put those into the Q&A window, which I'm pulling up now. I'm not seeing any questions or hand raised, so I'll go into a few questions that I had prepared for our panelists. Okay, first off, so in terms of our panelists that spoke here today, do you all have any recommendations for coordinating with the local authority having jurisdiction in order to ensure proper execution of facility modification planning? So I'll let you guys speak up with whoever wants to take that one first.
Hey, Paul, I'll go first. This Chip again. I think oftentimes one of the things that folks really don't understand is that oftentimes the AHJ folks, it may be their first time working with a CNG conversion on a facility. So they may not know all the answers. So I think my advice to our viewers is try to do your homework ahead of time, and work with a professional that really understands the codes, a design professional to evaluate your building and what you're dealing with, and do your homework ahead of time. And if you end up doing a pre-application meeting with your agency having jurisdiction, with the AHJ or with the building department on a pre-application type basis, basically have your plan of what you believe your solution should be, and have the requirements, so that the various requirements, the various codes, and go in to that meeting being prepared. Because I approach it more of here's what the requirements are, and then this is how we propose to address it. And I guess that's my feedback, because oftentimes, if you go into a situation like that where you say, what do you want us to do, you could end up getting into situations where you got to do a whole lot more than is what is really required to do to comply with the requirements for the upgrading the facility.
Thanks, Chip. And I think it's also good to reference this maintenance facility guidelines document that TTP published, because it does provide a thorough review of the code requirements in case there is a regulator or an AHJ representative that is trying to push requirements that aren't actually required per code. Then you can refer to the TTP document, and it just does a good job of providing all the specific clauses that you could help the AHJ understand what the requirements actually are.
Well, I would also say that I'd second everything that Chip just brought out there, but the thing that we also have accustomed to do at the end of the job, once we're through the permitting process and we're down to the day of turnover, or right before, we invite that same AHJ person out, whomever it may be, with local fire department, the fire marshal, the state fire marshal, the volunteer fire department, whomever it may be, to come and actually walk them through the modifications that you did to that facility and demonstrate the gas detection system, the exhaust fans, the heating system, and show them all of the attributes of the gas detection system and what you've done to improve that facility to make it safe.
Thank you, Jim.
If I might, I've been involved in several facility designs, both for a retrofit and brand new. And in a brand new situation, if you can become involved with the AHJs and ask them what their awareness is of the codes and standards, and sometimes you might be surprised that they have no idea what NFPA 30A or the IFC says about maintenance facilities. So we've actually put on a training program for the AHJs to educate them about what the codes require. And we have found that to be very effective in terms of when the drawings are submitted for review, that they feel a lot more comfortable. They still ask questions, but they feel a lot more comfortable with what they're looking at after we've had a chance to review the code with them and the code requirements. Also, you need to know what version of the code they're going to use, because if they start using the 21 or newer code, then of course methane detection becomes a requirement. But as was stated before, if you go before the 21 code, then continuous ventilation, which is a lot less expensive, could handle that for you.
That's right. Thank you, Leo. We are almost at time. Adam, I see you have your hand raised, but in the interest of time, I'm going to ask that you send in your question to me. Here's my email address. I'd be happy to follow up with you and put you in contact with our subject matter experts that were our panelists today. So psanstead@transportproject.org is my email address. And I will also try to follow up with William, who put in a comment into the chat. So with that, Jim and Chip, you guys probably thought you were going to get off easy without being recognized.
Oh, geez.
I had to bring it up. We are losing two subject matter authorities in the maintenance facility modification industry and in the NGV industry in general. So Chip and Jim, I just want to say with our deepest gratitude and appreciation, we thank you for your decades of leadership, dedication, and service to the NGV industry. Your commitment to advancing safety, innovation, and industry collaboration has helped shape cleaner, more reliable transportation solutions and has left a lasting impact on fleets, first responders, and communities across North America. We're so grateful for your influence, your mentorship, and your passion. We wish you all the happiness as you begin your next chapters in life. Congratulations on your retirement, and thank you for everything. So, thank you so much, guys. I really appreciate you taking the time, especially for Chip, this being his actually his day that his retirement party is happening later today in Houston. So hope you guys have a great time. Chip, Jim, we wish you all the best.
Thank you.
Thanks, Paul.
Appreciate it.
Thank you so much.
All right. So just a couple of closing remarks. Kirk, if you're on, you want to take these or should I? I'll take them. So just real quick, a few reminders. TTP will be hosting the RNG Roundup at ACT Expo later this year on May 6th. This is, of course, in Las Vegas at ACT Expo on Wednesday, May 6th. Feel free to reach out to me if you want more information. And also our TTP 26 Industry Summit will be held in Nashville, July 7th through 9th. Go to ttpsummit.org for more information. And we are also in the middle of a fleet drive with a special introductory rate of $2,026. You get a full membership for you and your team, and one free TTP 26 registration, one free DC flying registration. Kirk Ross is our membership director. There's his email address. Feel free to reach out to him if you want more information. And we encourage you to consider this offer to really gain the competitive edge in all these aspects. As a reminder, these slides will be provided in a PDF form and also as a recording link on our member portal. So this information will be available afterwards. That is all the time we have today. Appreciate all of our panelists for participating in the webinar today, and also all of their help and support putting together the guidelines document themselves. So with that, thank you so much. Appreciate everyone's time and support, and have a great day.